All right. Good morning, everybody. Today is Friday, January 12th, 2018, and this is Before the First Cup with Jules here on UCY.TV. Happy Friday, everyone. It is a very balmy and springy 60 degrees and drizzling here in upstate New York. All of our snow is melted. My yard looks a little bit wet, and we are going to go down to 14 today and have a hell of an ice storm, they're saying, and then a foot and a half of snow. So welcome to winter in upstate New York. So where do we leave off on Wednesday, which was our last live show? We had Mr. Clint Richardson on as guest discussing blockchain, property, identity, law, and the matrix. We looked at a bunch of different things. I wanted Clint to outline how property ownership, which you really don't own because it's all a falsity. What's the word I'm looking for? Not encoding, but the recording of property debt, let's say, as well as licensing and legalities, your legal person, are all recorded in contracts. Documentation. There's all kinds of mumbo jumbo law behind that, which he spent a lot of time studying and decoding. And I wanted him to kind of equate how blockchain and this moving everything to this digital ledger, which they say is immutable, never changing, so it'll be a permanent record for everything, how this is equating to the way things are done now and what that is going to mean for us. And at the very end of the show, Clint started reading a little bit out of a document that we had run across a while back titled Blockchain Thinking, the Brain as a DAC, which is a decentralized autonomous corporation, or they can call it a DAO, decentralized autonomous organization, not corporation. The first one was corporation. And I wanted to take a look at a little bit of that, look at blockchain, and then look at brains, because there's been a lot of brain news over the last few days. So out of this document where he ended the show on Wednesday, I'm going to look at the introduction. One great benefit of blockchain is that they are a new form of decentralized information technology that could be applicable to many situations beyond cryptocurrency, and that's where you know about blockchain from, and financial assets. The decentralized nature of blockchain makes them an equality technology. Now here comes the sales pitch. One that can be used to expand freedom, liberty, possibility, actualization, expression, ideation, and realization for all entities in the world, both human and machine. So step right up, because we are selling this to you as the answer to everything. The specific new kind of application that blockchains might enable is blockchain thinking. The idea of putting thinking on the blockchain, and more specifically, using blockchain architecture to instantiate thinking machines. And remember, all of this brain initiative is about reverse engineering the brain to be able to create better artificial intelligence. The objective is to formulate thinking as a blockchain process, which could have benefits for both enhanced human biological thinking and machine thinking or artificial intelligence. And this paper is intended as a forward-looking, highly speculative application of blockchain concepts in a new and explorative manner, but it does not consider the immediate feasibility, appropriateness, or risks of such implementation. Yeah, you gotta love when they don't look at the risks. So we'll continue a little bit more, and then we're going to look at some experimentation, some stories that have come out about mind uploading, because that's where this is headed. So now let's look at the definition of thinking. Thinking has always been intuitively conceived as computational, and it is just now that perhaps blockchain provides the additional functionality required to better realize these ideas. A fundamental definition could be that thinking is a situation where, quote, there are inputs which are processed and then turned into outputs, unquote. In fact, many reality processes have this underlying structure of input, processing, output, including operations as diverse as manufacturing and political elections. And those are two things. They are looking at putting the Internet of Industrial Things on blockchain so they can have interactions and exchange data in a trusted format between the devices, as well as potential creations of constitutions. And yes, of course, for all you people who think voting makes a difference, cast your vote for president as well. That could be in your future. And not just for your local president, but for your global president, as this brings everything under one big global umbrella. So for the context of blockchain thinking, the definition can be qualified to situations that involve thinking, cognition, mental processing, and understanding in ways that are not exclusively limited to humans. And inputs include both data from the outside of the system, like sensory data, and retrieved data from inside the system, like memory. The inputs are brought into a specific location for processing or processed where they are stored, and the outputs might include taking an action, storing something back into memory, conducting a transaction, or making a note or a trigger for some future action. It's an if-then statement. So now let's get to personal thinking chains. And this is some of this swarm thinking that we read about a few days ago, where you could have like a jury panel on a blockchain and have all these different entities out there in the distributed database casting their vote or checking the integrity and then giving their, I don't remember what it's called, some sort of consensus. This is all consensus based. Blockchains might be used to work with digital mind files, which would be uploads of full human mind files in the future. And their current prototypes, which would be your digital identities of Facebook, LinkedIn, etc., through their asset management, property registration, and access control features. There could be personal thinking chains as a life logging storage and backup mechanism. And the concept is blockchain technology plus in vivo personal connectomes to encode all of a person's thinking and make it useful in a standardized compressed data format. The data could then be captured via qualified self-tracking devices, wearables, intercortical recordings, consumer EEGs, brain-computer interfaces, cognitive nanobots, and this is what Clint was reading, and other methodologies. And through the transactional logging of this data, the basis for thinking could be insubstantiated in a blockchain, and really all of an individual's subjective experience, possibly eventually their consciousness, which could allow consciousness to be more precisely defined. Once on the blockchain, the various components could be administered, ding ding, and transacted, meaning engaged, for example, in a case of post-stroke memory restoration. I remember reading that before. Yeah, a lot of these brain technologies, to my horror, are coming out to help those poor stroke patients who have lost function and memory to be able to fix their brain. Step right up, Jewel, and get another CAT scan or fMRI. So there has not been a good health data commons model with the appropriate privacy and reward system for the public sharing of personal health data and quantified self-tracking data, and likewise mental performance data. So blockchains might prove exactly such a structure for creating a secure, remunerated, owner information controlled health data commons. And it'll be that dangling carrot to get you to feed all of your biometric data. Wearing sensors of one kind or another, or getting scans and uploading them to the blockchain so they can have you in a big centralized database to turn the AI onto, to manipulate and control. That's how I see this ending. This isn't going to end well. At the individual level, personal health is a big data problem that needs effective universal orchestration, security, and access mechanisms like blockchain technology. You know, I had watched a TED Talk or something not too long ago on uploading medical files to blockchain, and one of the things that they've been talking about is, oh, what a great tool this would be, because we could put all of the brain scans, all of the CAT scans up onto blockchain. And that just makes me think, as they turn AI onto blockchain technology and they let it run and collate, bag, and tag everything that is in this database, this is going to give it access to everything that they know about you. And not only that, but they can assess the type of person you are just by your brain scan. And we're going to read about that in one of the stories coming up here. At the social level, and they can tell if you've ever even done drugs just by looking at your brain. At the societal level, the argument for blockchain technology is even stronger because they're really going to push this in your face. Medical research needs access to big health data for discovery, too. Remember, check that box. And the premise of machine learning revolution has thus far not been realized in the context of health because the data is still siloed and in any case digitally uninteroperable, and blockchains could be employed as a secure, large-scale data management mechanism to coordinate the information of millions and even billions with a B of individuals. All right, one more little bit here, and then we're going to jump into brains. Personal connectome files. Well, how do we get those? Well, I actually have a diagram somewhere. I'll try to post that in the notes to today's show. Just like your personal genome files and your electronic medical records, we're going to talk about personal genome files. They're talking about uploading those to blockchain as well. Could be registered and orchestrated via blockchains. A personal connectome file is your own mind file, the anatomical and functional mapping of your own brain. And it is hoped in the future that connectomes might make it possible to share not just quantitative information about your brain state, but also qualitative experience like sentiment, affect, valence, and what it's really like to be you in that moment and what you were thinking at any time. And this could finally be an answer to subjective experience questions as to whether I see red the same way you do or what it is like to be a bat. I kind of like bats. The idea would register the personal connectome files on the blockchain just as your electronic medical records and your genomes do now. And the files are not literally stored on the blockchain, but a blockchain registered transaction provides a unique ownership signifier and includes pointers to files which are stored securely in decentralized off-chain locations. Thus, health record blockchains could be used to denote ownership and manage access to these kinds of sensitive data files. And blockchain-based coordinated systems could also be ideal for personal health and records management, for privacy, security, access control, and just the sheer administration, because big data means that there are billions of data elements that may comprise any one individual's health file. So look out, because they are coming for your information. Now, here we go. I had a slide up in this presentation, but it had gone back to page 1. So there was a presentation that I had found on slideshare.net the other day that was about this document that we were just reading, talking about blockchain thinking, the brain as a DAC. And there was a woman who wrote a really wonderful book, and it's out there somewhere in PDF. Maybe if I still have it, I will link to it. It is titled Blockchain, and I can't really see because it's so tiny. But it's by a woman named Melanie Swan. She seems to really get some of what is going on here. She's a researcher, and I think she might be out of, it says Purdue University, but I thought she was out of MIT, but maybe she does stuff at both. But the one slide really caught my attention because it is titled Future of Diverse Thinking Entities. And somewhere in the middle, a little bit off to the left, is one notation called digital mind file uploads, which is what we were just reading about. But I want to read some of the other things that are in this future of diverse thinking entities. It's just that title's got to scare you a little bit. So we have, of course, supercomputers and AI agents, not named Tay. Smart contracts, of course, which are part of some of the blockchain technology. Deep learning clusters, which we've read about those. Artificial life, which is the next step beyond synthetic biology and some of the stuff that Craig Ventner's been working on. Machine learning algorithms, the Internet of Things and smart networks, autonomous cars, autonomic computing, synthetic biology, of course, smart home networks, simulated minds, which they are already working with that, some of the deep mind stuff from Google, designed life. And remember, this is human-directed evolution per Georgie Porgy Church, whole brain emulations, Expert systems. Now, that's something that we worked on quite a number of years ago in some of the application development that I was involved with. That is making, like at a call center, when you call in, it will recognize who you are based upon your caller ID. And it'll check, because you're connected to a network, it'll check your connections. Let's say if you were connected to some sort of paid network like a streaming service or whatever, based upon your caller ID, it'll know who you are, and it'll go out and ping your devices and go, oh, look, this is up, this is down. And then when it routes your call to the proper call queue and the call center agent answers the phone, it can pull up your account information. And based upon the problems that it detected, it could be encoded in the software for that call center agent to have certain questions to ask you, like, oh, are you having problems with this? Are you having problems with that? Well, why don't you reboot, turn off the power, unplug it for 30 seconds, and then turn it back on and let me know what happens. We're going to reset your password or your stream or whatever. And guys, I mean, that's been around for a very long time. That was a lot of going back to old school phone system networking and the interactive voice response systems and that type of stuff. So expert systems have probably been around for, I would say, close to 20 years in some form or another. Then, of course, we have brain scans, brain-computer interfaces, which we've spent a lot of time looking at. Natural language processing, and that's some of the stuff that Kurzweil has worked on for his entire life. Enhanced humans and animals. We talked about those little mousies that had those human mini-brains implanted, as well as hybrids and high-frequency trading networks, which that caught my attention too, because you always have to tie that financial industry into things. We found out that there was maybe some question about the legality of having artificial intelligence doing high-frequency trading on Wall Street, but now they're even talking about putting stocks onto blockchain. Though, I don't know, blockchain's kind of slow. That's one of the underlying issues they have with the technology. Each time there is a transaction added to the database, every single computer that is involved in that peer-to-peer network that is doing all of the back-end processing has to take an entire copy of that encrypted blockchain and process it on their computer. So as the database gets bigger and bigger, and as you add things such as CAT scans and huge amounts of data, it's going to take longer and longer to process each new record that is added to the database. So that's about all that's on that slide, is the future of thinking entities. So what are the top 4 killer applications for the brain as a decentralized corporation or organization? Well, thinking is a blockchain process, of course, as input, processing, and output. And for artificial intelligence, they could use it to create friendly AI, and that would be friendly AI by consensus, and blockchain deep learning. But don't worry about it, because we could also use it for human enhancements for those of you who are ready to upload yourselves to be forever trapped in the digital realm after death or even before death. And they have their Mindfile services that they are looking at. So where do we go from here? Well, that leads us to a story out of Popular Science titled Neuroscientist Who Wants to Upload Humanity to a Computer. And you knew this was going to happen, and here it is. The neuroscientist who wants to upload humanity to a computer, his name is Randall Cohn, and he is recruiting top neuroscientists to help him make humans live forever. Now, we haven't talked about them running after that live forever dangling carrot for a very long time, but don't worry about it, because they didn't stop working on it. Everything felt possible at the Transhumanism Visions 2014, which was a conference held in February, built as a forum for visionaries to, quote, describe our fast approaching, brilliant, and bizarre future. And I would say that I echo that sentiment. Inside an old waterfront military depot in San Francisco's Fort Mason Center, young entrepreneurs hawked experimental smart drugs and coffee made with a special kind of butter that they said, yeah, it's wink, the special kind of butter, that they said provided cognitive enhancements. A woman offered online therapy sessions, and a middle-aged conventioner wore an electrode array that displayed his brainwaves on a monitor as multicolored patterns. So look how pretty those colors are. And on stage, a speaker with a shaved head and a thick black beard held forth on a DIY sensory augmentation, a group called Science for the Masses. And yeah, that's exactly what we want. I don't know, maybe I'd call my show Anti-Science for the Masses. He said was developing a pill that would soon allow humans to perceive in near infrared spectrums in a pill. Now that's crazy. Don't swallow it. And he personally had implanted tiny magnets into his outer ears so that he could listen to music converted into vibrations by a magnetic coil attached to his phone. And don't worry about it, because you also have little magnetic coils, we found out last week, underneath your skin. None that work in the millimeter wave spectrum. None of this seemed particularly ambitious, however, compared with the claims soon to follow. In the back of the audience, carefully reviewing his notes, sat Randall Cohn, a bespectacled neuroscientist wearing black cargo pants, a black T-shirt showing a brain on a laptop screen, and a pair of black shiny boots. Cohn had come to explain to the assembled crowd how to live forever. Quote, as a species, we really only inhabit a small sliver of time and space, Cohn said when he took the stage, and we want a species that can be effective and influential and creative in a much larger sphere. So listen to what I have to sell you. So Cohn's solution was straightforward. He planned to upload his brain to a computer, and by mapping the brain, reducing its activity to computations and reproducing those computations in code, Cohn argued that humans could live indefinitely, emulated by silicon. When I say emulation, you should think of it, for example, in the sense of emulating a Macintosh on a PC. He said, it's kind of a platform-independent code. The audience sat silent, possibly awed, or maybe even horrified, possibly confused, as Cohn led them through a complex tour of recent advances in neuroscience, supplemented with charts and graphs. Cohn had always had a complicated relationship with transhumanists who likewise believe in elevating humanity to another plane. And a Dutch-born neuroscientist and neuroengineer, Cohn has spent decades collecting the credentials necessary to bring his fringe ideas in line with mainstream science. Now that science is coming to him, researchers around the globe have made deciphering the brain a central objective, and that's what should scare you, because the brain is what makes you what and who you are. And once they crack all those codes, nothing will be sacred anymore. In 2013, both the U.S. and the EU announced initiatives that promise to accelerate brain science in much the same way that the Human Genome Project advanced genomics. And remember, we read some of that presidential edict at the time from Obama, announcing the Brain Initiative and how much money that's going to make us. It's going to be a whole new industry that is going to launch science like the Human Genome Project did. The minutiae may have been lost on the crowd, but as Cohn departed the stage, the significance of what they had just witnessed was not, and the knowledge necessary to achieve what Cohn calls, quote, substrate independent minds, unquote, seems tantalizingly within reach. The concept of brain emulation has a long, colorful history in science fiction, but it also is deeply rooted in computer science, and an entire subfield known as neural networking is based on the physical architecture and the biological rules that underpin neuroscience. Roughly 85 billion individual neurons make up the human brain, each one connected to as many as 10,000 other branches called axons and dendrites. And every time a neuron fires, an electrochemical signal jumps from the axon of one neuron to the dendrite of another and across the synapse between them. It is the sum of those signals that encode information and enable the brain to process input, form associations, and execute commands. Many neuroscientists believe that the essence of who we are, and not just neuroscientists, but people like Jules, our memories, emotions, personalities, predilections, and even our consciousness lies in those very patterns. In the 1940s, when they were allowed to do science, neurophysiologist Warren McCullough and mathematician Walter Pitts suggested that a simple way to describe brain activity was using math. Regardless of everything happening around it, they noted a neuron can be in only one of two possible states, just like a binary computer, the active state or the rest state, and there would be the on or the off state. And early computer scientists quickly grasped that if they wanted to program a brain-like machine, they could use the basic logic systems of the prototypes, which were binary electrical switches symbolized by ones and zeros to represent the on-off state of individual neurons. Ding, ding, ding. So a few years later, Canadian psychologist Donald Hebb suggested that memories are nothing more than associations encoded into a network. And in the brain, those associations are formed by neurons firing simultaneously or in sequence. For example, if a person sees a face and hears a name at the same time, neurons in both the visual and the auditory areas of the brain will fire, causing them to connect. Making dots connecting. And so the next time that a person sees the face, the neurons encoded with the name will also fire, prompting the person to recollect it. So using these insights, computer engineers have created artificial neural networks capable of forming associations or learning, and programmers instruct the networks to remember which pieces of data have been linked in the past, and then to predict the likelihood that those two pieces will be linked in the future. Today, such software can perform a variety of complex pattern recognition tasks, such as detecting credit card purchases that diverge dramatically from a consumer's past behavior, indicating possible fraud. Like when you get that email and they say, we've detected anomalous activity on your credit card account. Please click here to confirm. So, all right, so this Cohn, this neuroscientist that gave this presentation about uploading brains to the machine, is also involved with a company called Kernel, which is involved in similar technologies, that is for brain-computer interfaces and implants, to be able to garner information from your gray matter, to be able to potentially in the future make a digital version of you. And I found out he's also involved in another company, and he is giving a workshop live stream a couple Sundays from now, Sunday, January 28th, 2018, starting at 8 a.m. Pacific Standard Time to 7 p.m. Pacific Standard Time, being live streamed on the internet, and it is titled Transcending Biology. So this is if you want to see this guy speak, Reverse Engineering the Brain. And the name of the company that he is giving this for and that he is involved with is called Carbon Copies. Yes, guys, I said it. Carbon Copies. It's a Black Mirror episode. CarbonCopies.org. And I will link to this in the notes as well. On Sunday, January 28th, 2018, the 501c3 nonprofit organization Carbon Copies is hosting a public workshop on whole brain emulation and mind uploading. Attendance online or in person is free of charge, and the workshop is designed to both introduce whole brain emulation and the Carbon Copies organization, as well as provide an update of the current status and their activities. The workshop will emphasize participation through Q&A and topical discussion, and the agenda includes the following topics. 1, mind uploading. What a great way to start. A brief introduction into the philosophy, science, and technology of mind uploading and whole brain emulation. Number 2, Roadmap 2018. That's where we're going forward. The Carbon Copy Status Update. How do we map the structure of the brain, and how do we record the response characteristics of its neurons and its synapses? How is working model generated within parameters defined by those data maps? And how is a model brought to life in a real implementation of whole brain emulation? Number 3, he's going to talk about some of his other commercial efforts, and that would be Kernel, as well as Elon Musk's Neuralink. And those would be commercial efforts to bridge the machine-human divide. Are you guys starting to see some connecting dots here? Bringing machines and humans together and allowing them to think together and to exchange information between each other seems to be a very unifying goal with some of these people. They want to get into your brain. Number 4, Carbon Copies Technology Review. We're going to take a look at how they do it and launching of this research project. And number 5, Special Topics, Discovering Neural Circuits in Brain Data. Presenters include Dr. Randall Cohn of Carbon Copies, as well as Dr. Diane Decca and others, and everyone is invited to attend and participate. The workshop is designed to be accessible to newcomers, and we look forward to your attendance and your participation. See you there, because we want to sell you this technology and tell you how you can live forever. We're trying to get more converts. And I don't know, I really want to watch this entire thing. I am going to be out and about on that day, so I'm going to have to watch the recorded version. But I wonder if this is going to make me feel dirty after watching this. Because this is horrifying stuff, guys. This really is the stuff of nightmares. And there are real people, and people who have been in the neuroscience industry that are really working on this seriously with lots of different funding. So, okay, let's look a little bit at the agenda, and then we're going to move forward. So the workshop agenda, the different titles of the sections. Number 1, this is mind uploading. And why humanity needs it. Yes, because you need this. Number 2, Roadmap 2018. Where are we now? Number 3, Kernel and Neuralink. Number 4, the Carbon Copies Technology Review. And number 5, Discovering Neural Circuits in Brain Data. And they're going to go ahead and show you how to encode this stuff and how we can upload it, maybe even to the blockchain for mind uploading, Mindfile uploading. So, all right, talking about putting data, and that would be how your body works, different biological data on the blockchain. I want to mention a company or a group that a listener dropped me the other day. Thank you, Keith. This is a company named GeneCoin, and I must have missed this one when they originally came out, so we're going to talk about them briefly. I mentioned them in the discussion with Clint the other day, but really didn't get to expound on it. GeneCoin.me is their website. GeneCoin. Make a backup of yourself using Bitcoin. Yes, a backup. Spread your DNA across the globe. And oh yeah, that sounds like a very good idea. GeneCoin samples your DNA, then turns it into data, and then stores it in the world's most powerful supercomputer, the Bitcoin network. Humans currently preserve their genes by passing them down across generations, and this is an incredible but ultimately unreliable backup method, you puny humans. We etch your DNA into the culture's most indestructible form, and that would be we etch your DNA into money itself. What? Yeah, I mean, how is that a good thing? GeneCoin puts your DNA on thousands of computers across the planet. I mean, just that's got to tell you this cannot be a good thing. So then the next section is become data. First, we turn your DNA into data. And this is actually called genome sequencing, in which we outsource to biotech companies that specialize in DNA, and they don't name any commercial entities, but I'm going to think it's somebody like 23andMe, and you'll receive an easy-to-use sampling toolkit in the mail, and then we take care of the rest. So here, just spit in this vial, and then package it back up, self-addressed, stamped envelope, and we'll take care of it for you. And then it continues with a little arrow, and it says, become currency. Well, yeah, why can't we all become the dangling carrot? Next, we will upload your genome data into the Bitcoin network, and Bitcoin is more than just a currency. It can actually be stored as any data, and we use it as a permanent cloud backup for the most important data ever, and that would be you. So don't just upload all of your brain scans. Give us all your DNA as well. So we are gauging the market interest. Tell us what you think. Should this technology exist? Do you want to spread your DNA across the globe? Yes or no? And I'm going to click a big red no. No, I do not want to spread my genetic material across the globe via Bitcoin. Thank you very much. So now let's go to the FAQ section. What is GeneCoin? Well, it is a service to back up your DNA. We will help you get your DNA sequenced for just $29.95. and we're going to put it on sale at Christmas time for you to give Aunt Susie and your mom. And then you upload it into the Bitcoin network. This spreads your genetic material to thousands of different computers all across the globe via blockchain. Well, how does it work? Well, we will send you a kit to collect a spit sample, I told you, and then it gets forwarded to the DNA sequencing provider that creates a data version of your genome. And finally, we store this genome in the blockchain for Bitcoin. Well, Bitcoin can store data. What is a blockchain? Oh, my God. I heard it buzz, and blockchain is going to make me lots of money. So is that a good thing to upload my DNA? Because I'm sure that's what people are thinking. Well, most people think of Bitcoin as a currency, but this is only one use of its protocol and its network. Bitcoin is really a networked ledger, and that is a way of permanently storing information, wink, on thousands of computers across the globe. And every computer that mines for Bitcoin stores this ledger, which makes it an extremely robust yet slow way to back up data. We have a number of strategies for encoding your genome data as Bitcoin transactions. Well, isn't a genome very large? Well, yes, of course it can be. And we offer various levels of service. A human genome can contain up to 3 gigs of data if encoded inefficiently. We use a 2-bit per base, which brings a full genome to about 750 meg. And most users will only need to store the data that makes them unique from other humans and life forms, so we don't get confused when we make carbon copies of you, which brings the file size down drastically. We can also offer various levels of sequencing depth depending on the interest and the cost that our users want to pay. Well, can my data remain private, spread across thousands of machines across the globe? Well, yes, you likely will want your genome encrypted before you upload it into the Bitcoin network, and your identity and your data can remain private as you want it, and we don't even have to see it. You can encrypt it on your own computer, then send us that data. And then all we have to do is the hard work of uploading it to the Bitcoin network. And well, how do I retrieve and decrypt my genome after it's been stored on the Bitcoin network? Well, at launch, we will provide you with software that can extract and decrypt your genome from the blockchain. We are also working with providing a number of exciting alternative strategies. Using decentralized oracles, split keys, multi-sigs, decentralized programming languages like Ethereum, and other strategies, you will be able to set up advanced algorithmic contracts that initiate autonomous transfers and decryption of your genome at a time or a condition of your choosing. So if your doctor said, hey, we need genetic information on Susie or Nana, we push a button and you have already given permission to the doctors at such and such hospital that you are affiliated with. They will then get an autonomous key that unwraps all your genetic data and hands it over to your healthcare professional. That's typically how autonomous sharing of contracts would work. So is GeneCoin an altcoin cryptocurrency like Litecoin or of Dogecoin? Well, at the moment, no. GeneCoin uses the Bitcoin protocol as an abstraction layer, and it is similar to a counterparty master coin BitShare. But what if another cryptocurrency replaces Bitcoin? Will I get erased? Well, don't worry about it, because we are developing decentralized blockchain crawlers, and they will be programmed to search and discover new blockchain technologies and then embed your genetic material wherever possible. So think of this as your robot friends, yes, your robot friends, that encode your genetic material on new networks that it finds as they develop. Similar to the way that Google discovers new websites, we will be able to jump from chain to chain. And our aim is to turn GeneCoin into a decentralized, autonomous organization, oh, there you go again, that preserves your genetic material indefinitely. So if other blockchains replace Bitcoin, our crawlers will make sure that your genome is propagated across all of these new chains. This sounds really frightening. Can my genome itself be traded as currency? Can I actually become money? I want my DNA to be the next Dogecoin. Well, once you're within GeneCoin, we recommend that you use your genome as seed data to then create your own altcoin. And this was a pretty intriguing idea. I could see a lot of people doing this. We could create a jewel coin. Services will soon let people create their own alternative cryptocurrencies with a single click of a mouse and their own DNA. Altcoins will function like applications or even personal brands, and in the near future, every person will have their own altcoin and a small community who is using it. With GeneCoin, your personal brands can become a mechanism for propagating your genetic material all across the globe in digital format. Hey, think about this. Think about, they tried this All of Us program, step right up and give your DNA to the researchers to put in the National Institute of Health research database, and we can make bazillions of dollars on your genetic data in making new drugs that can target areas that are faulty in the genome by just looking at the big data database. Well, now we've gone one step beyond the All of Us program. It was originally called the cohort program. Check this box, because now they're going to dangle a carrot, become an instant billionaire with your own DNA-branded GeneCoin. Well, how can my personal cryptocurrency's popularity preserve my genome? Well, step one. Use GeneCoin to back up your DNA in the most popular decentralized blockchain, and that currently is Bitcoin. Number two, generate your own altcoin using your DNA's Bitcoin address as a seed. And number three, this makes your altcoin a decentralized hyperlink back to your DNA, and the more popular your altcoin, the higher you'll be ranked by blockchain crawlers. If you have a popular altcoin that acts as a hyperlink to your genome, then your DNA will be propagated far and wide. And it's like kind of a bird eating a seed and then pooping you out all over the place. So little plants grow everywhere. It is like a search engine optimization meeting genetic preservation. Imagine if your website's rank on Google could determine how well your genetic material gets propagated. This is the future, which I really hope it isn't. GeneCoin helps strengthen your network's fitness by giving you a master backup of your genome alongside a strategy for hyperlinking it to your own personal altcoin. Of course, you can encode your genome into your own altcoin as well, but for ultimate backup, you want to encode it in the most widely used blockchain, and as of 2014, that was Bitcoin, and it probably still is. So what is the goal? Well, we just want to help humans transition into the era of all data everything, and that would be the Internet of Everything and network fitness. Plants evolved that their seeds could stick to birds' wings, right, or be eaten and pooped out. And as birds fly, they carry plants' genetic material to uncharted foreign lands. We want that to be your DNA. Similarly, our crawlers will spread your genetic material to foreign blockchains all across the globe. And GeneCoin is inventing new birds for the decentralized digital era. Now, if that wasn't enough to scare you, not that I'm all about fear porn, but just about everything we cover is fear porn on the show. Yet it is daily news that comes up in my crawlers. And what is going on here? Uh-oh. We might have to do the elephant song because Chrome is deciding to take a crash on me. All right, this is out of statnews.com, dated January 9th, 2018. Faced with public pressure, research institutions step up their reporting of their clinical trial results. Now remember, not only do we have all of this cohort type programming going along, but once you go to a hospital or you have some sort of procedure done, one of the things I noticed when they had me inking documents in my drug-induced haze with all kinds of IVs hanging out of my arm is they had me sign and check that box saying that, yes, as a part of my treatment, I would agree to allow them to use some of the tests that they did on me in the research database and some of the things that they were collecting to be able to further, quote-unquote, medicine forward. Well, the reporting of clinical trial results to a public database, which was mandated by a 10-year-old federal law, has improved sharply in the last few years, with universities and other nonprofit research centers leading the way, according to a new stat analysis of government data. Overall, trial sponsors had disclosed only 72% of the required results to the federal clinicaltrial.gov database as of September 2017. That compares with 58% just 2 years earlier. Unreported research data can compromise the safety of human research. Right, remember we talked about that a long time ago. Back just a few years ago, doing research on humans was considered unethical. Do you remember that? We did not do research on humans. We only did research on animals. But then with the advent of the 21st Century Cures Act and getting that pesky FDA right out of the way, research on humans utilizing 21st century technologies and mad science gone mad, all in the name of providing you cures, became ethically acceptable. And now it's all in a big public database to accelerate more human research. Unreported research data can compromise the safety of human research and slow the pace of innovation. Oh, God forbid. And the increase coincided with sustained attention on the problem by advocates for transparency in science and the media. And even then, if you remember, we talked about this and listened to part of this lecture he gave, Vice President Joe Biden, who was talking about the Cancer Moonshot Project. And they actually had Jennifer Doudna, who stepped up and had something to say about all that. And she was one of the people who was instrumental in bringing CRISPR to life. Especially striking were the increases at major research universities, and we've covered a lot of that. It has been actually very striking, and what kind of information that they are working on. They're trying to crack all of the chinks in the human armor, which conducts the vast majority of academic trials, and their reporting jumped from 58% to 77% of trials. The National Institute of Health and top recipients of its funding did even better, which is a sign that leaders in academic medicine are finally taking seriously after a law that required the reporting of the results of most human studies of medical treatments. So many of the biggest gains were research institutions singled out for woeful reporting in the earliest stat investigation. And that would include Sloan Memorial Kettering Cancer Institute, the University of Pittsburgh, and Stanford University. And such formerly routine violators improved on an average from reporting the results of just 35%, right? Because that was research that was being funded and was being done down dark, long hallways. And we put everyone on notice that we consider this an extremely high priority, even for busy and sometimes recalcitrant faculty. STAT was the first to examine the reporting track record of individual institutions, and the improvement by the worst offenders suggested that naming names drove better reporting because it was embarrassing. But it's got to make you worry because they were doing all kinds of clinical trials, and remember, that's where you have that dangling carrot. Either you live or die, and hey, we have this mad science thing that we haven't quite tried on humans yet, wink, but it could help you, so step right up, our most vulnerable, because we want to prey upon you and have you help us figure out how to merge man with machine. So here's another story out of ScienceTrends.com. Can machine learning fMRIs be a computer-aided diagnostic tool for brain diseases? So we take another step further into mind uploading. Recent statistics show that about half of the U.S. population suffers from at least one type of health problem that includes mental illness, substance use disorders, or even chronic medical conditions. Substance use and mental disorders are both considered brain diseases. So, of course, we want to diagnose everybody as having a mental disease in the future. Brain disorders are a major worldwide problem that also is pointed out in studies analyzing data from the World Health Organization. And a better understanding of these diseases includes techniques for diagnosis and treatment to impact and improve global life expectancy. Intensive research has been performed to study Alzheimer's, of course, traumatic brain injury, Parkinson's disease, schizophrenia, Huntington's disease, as well as addictions. And that is part of the 21st Century Cures Act, as well as a lot of the things, and they didn't even talk about PTSD, a lot of the things that DARPA has been funding as well. And research suggests that brain diseases change both the brain wiring and the functioning. Brain connections can not only be damaged, but can also be rewired as a compensatory mechanism. So we're going to figure out how to rewire you when you need some attitude adjustment. The fact that some humans can live with only about half of their brain provides a very good example of this adaptability. There is a great interest in disease-related changes, and the configuration of brain connectivity has the potential to be an indicator or biomarker for the existence of brain disease or the prediction of future outcomes. Right, we're going to do a brain scan, and then we're going to be able to say that at some point in the future, Johnny, you have all the telltale signs that you're going to become a problem person, predictive mental illness, and we're going to rewire you in a precog sense, so that never happens. One way of measuring brain functions is to use a non-invasive method such as MRI or EEG to observe the brain while humans individually perform an activity. This procedure is not always convenient in the context of a biomarker discovery, but one example is the ability of humans to learn and improve task performance, which could interfere with diagnosis. There is also the difficulty for certain patients to perform tasks, and for these reasons, observing the brain at rest without the intervention of a particular task is a promising approach for individual subject prediction, which does not require individuals to perform a task. During the resting data experiment, a person is requested to rest without performing any particular course of action. No particular consensus is yet adopted to determine whether the eyes should be left open or closed. I would say probably closed, because even if your eyes are open and you're not doing anything, you're still processing data. You should probably put earplugs in as well, or be in a sensory deprivation chamber. It would probably even be better with an EEG on top of your head. However, open eyes may help reduce the possibility of sleeping, and in many cases, a slight fixation item is used to aid the scanned person. Yeah, the scanned person. And in some cases, eyes are monitored by the staff outside of the scanner. This makes me think of A Clockwork Orange. Through the analysis of collected data, a resting state brain connectivity pattern emerges, and at this point, we can use analysis approaches to identify patterns in brain activity that show activity consistent with a healthy brain, and abnormal deviations, remember, that would be operating outside of defined parameters from a healthy connectivity pattern, can indicate the presence of brain disease. Two brain regions or networks can be connected in various ways, and anatomically, two regions can be linked by physical extensions of neurons called axons. Two brain regions can also show statistical similarity, and that would be showing functional connection. And these connections are not necessarily active all the time, but don't worry about it because brain function changes beyond the brain structure. The most notable change was an increase in the functional connectivity between the cerebellum and the brain areas of processing, movement, or your motor neurons. And this increasing of functional connectivity may be indicative of the brain sinking to compensate for injuries. So how do we mining? Let's do brain mining. Mine for connectivity features. Well, the brain complexity makes it difficult to identify which functional connections are useful in identifying brain diseases, but it is very important for diagnostics, and many machine learning techniques are natively built to look for the influence of combined features in a multi-dimensional manner, like maybe using things such as MRI, genetic information, or chemical processing, which can be extracted from the very same subject with relative ease, using several techniques that have been developed to allow for a more precise characterization of brain diseases by fusing features from several modalities into one AI analysis. So, all right, now let's go to Singularity Hub. It is titled Naughty or Nice. One brain scan now is all it takes to find out. With a simple scan of your brain at rest, which would be that same experiment we just read about, scientists can now guess whether, on average, you are naughty, or if you are nice, is going to become the AI Santa. We now have begun to see really strong evidence of a connection between measures of brain function, connectivity, and many aspects of people's lives and their personalities. The surprisingly strong correlations published in Nature Neuroscience are the very first to emerge from an ambitious human connectome project, a global effort that seeks to map all of the pathways between the brain's hundreds of regions and millions of neurons, and then relate those back to a connectivity pattern to personality and behavior. So stated Dr. Sebastian Sung, a computational neuroscientist at MIT, in a 2010 TED Talk that propelled the nascent field of connectomics to the public limelight. In one sentence, Sung touched on two provocative ideas. He said that people's self-identity, their personality, their habits, their lifestyles, their memories, and their experience are all stored in functional connections in our brain, one of which Cohn hopes to upload to the machine. And if you disrupt that connectome, such as cases of schizophrenia, we actually lose our core identity. And the other idea was more of a scientific prophecy, and that would be by advancing brain imaging, we may be able to map out the wiring and maybe even upload it to the blockchain. All right, guys, have an awesome Friday, and I will catch up with you maybe Monday. Everybody take care.